right. Thank you everybody for joining. We're just gonna get right into it. So this is a presentation on DataWeave. We're gonna keep things simple and kind of focus on the basics. So real quick introduction of who I am. My name is Joshua Ernie. I'm a MuleSoft ambassador. I've been working in the MuleSoft space for about 5 years now as a developer and architect. I'm a DataWeave aficionado, and I blog at journey.io. Mostly about DataWeave, and occasionally I get into some other things as well. So the purpose of this talk is to really kind of help beginners get a more solid understanding of what DataWeave is, the problem that it's solving, and how they need to be thinking about how the language is working when they're designing their solutions. I remember when I started working with DataWeave a few years ago, the big problem that I ran into that I didn't realize until recently was that I was trying to learn two pretty big things at one time. I had to learn functional programming, and then I also had to learn about the topic of this talk, which is how DataWeave is transforming between MIME types and its own data types. I was unknowingly tackling those two things at once, so the goal of this talk is to kind of untangle those two things. I've talked about functional programming a lot in my other talks as it relates to DataWeave, and I have links to those presentation slides at the end of this particular presentation. And I'll try to remember to, the link is pretty unwieldy, so I'm gonna try to remember to put that in the chat at the end so you can just click on it and go to the presentations. So the topic of this talk is really just talking about how DataWeave is moving between MIME types and its internal data types. So let's get an understanding of the problem that DataWeave solves. So let's say that you're building an application and it's not a MuleSoft application. We're just using pure Java, and we have an application that's receiving in data from, it's receiving in XML data from this system, CSV data from some FTP server somewhere, and JSON data from an API that it calls at some point. You as a developer or an architect are responsible for choosing the library for each one of those MIME types. And as you can see from the list I have here, there's a lot of choices. Each one of those choices has their own strengths and weaknesses. Some of them are much more popular than others, like Apache Commons versus Univocity for CSV, for example. I hadn't heard of Univocity until I was doing this talk, but Apache Commons is pretty prolific throughout the community. So once you get into parsing these data formats, you're immediately strapped with a lot of responsibility and a lot of decision-making that you have to make that are gonna have some repercussions down the road. For some of these formats, the choice is fairly obvious, like JAXB seems to be the standard choice when you're working with XML. I've seen Jackson and JSON used pretty evenly through some Java projects that I've used. And Apache Commons and OpenCSV are very popular CSV libraries. But there's still a problem once you wind up picking one of these particular libraries for each one of the MIME types that you deal with. And that is that each one of these different libraries is going to have a different API. So you're never going to be looking at CSVs the same way. If you're using Apache Commons versus OpenCSV, you're going to be dealing with different data types, different objects, different methods on those objects. So the way that you have to think about how you're working with these libraries changes for each one. And that winds up being a pretty big burden. So it would be really nice if there was just a single library that we could use that would give us the ability to do all of these parsing of these data structures into, for example, Java, getting them into Java objects, just something that simple. If we could have a library for that, it would be great. If it had a consistent API across all of these different MIME types, that would be wonderful as well. So instead of having to deal with like an XML object and a JSON object and a CSV object, we just have objects, or just we have arrays. That'd be nice as well. It'd be nice if this single library just supported all of the data formats that we could conceive of. And in addition to that, it'd be nice if we could extend that library and maybe support some MIME types that the authors of the library didn't anticipate when they created the library. So this is one of DataWeave's primary benefits. It's one of its main areas of focus when it comes to providing a solution for this problem that we just talked about. Oh, I just wanted to mention something real quick. I do have a section at the end for questions, but I would say if you guys do have questions, feel free to leave them in the chat. I have the chat open on a different window, so I'll be kind of eyeballing that. And I'm more than happy to take some time and answer questions throughout the presentation, as opposed to stopping and waiting at the end. So asking a question here, how does DataWeave create a uniform API for manipulating all of these data formats? Because that's really its strength. Well, to answer that question, we have to distinguish between MIME types and data types. Now, MIME types and data types are similar in that they're both metadata, and that just means they're data that describes other data. It's kind of a weird definition, but for example, an example of a MIME type would be application JSON. And you can use that piece of data, this identifier application JSON, to describe a file, for example. So this piece of data, application JSON, is describing the data that's in the file. And that's how we come up with this term metadata. Now, MIME types are used to describe the format of data either at rest or in transit. And they're really good for standardizing inter-program communication. So if I have one program on this machine, machine A, and I have another program on machine B, and they need to talk to each other, it would be really beneficial for them to agree on a MIME type before they start passing data back and forth. That'll make communication between them a lot easier. So data types, on the other hand, are good for kind of not really doing communication within a program itself, but they're good for kind of relaying intentions about, hey, this variable should only receive these kind of values, and this function should only receive these kind of values and return this kind of value. So just as a quick refresher, MIME types are used for passing data in between different programs running on different servers mostly, and data types are used to basically describe what kind of values are living within a program, what's acceptable to do, and things like that. So if we take a look under the hood at how DataWeave is doing this, we kind of come up with this picture. Now, the data moving in this particular diagram is moving from left to right. So we have our data coming in, it goes into a reader, it goes into the DataWeave script where it will transform the data, and then it goes into the writer, and then we have data out. Now, most people, at least for me personally, when I started working with DataWeave, my view of DataWeave was if you just took out those yellow boxes, that's what I thought DataWeave was. And that caused a lot of problems for me. For example, like I'm trying to, this is my first or second year using DataWeave, and I'm trying to still figure out how can I format my code the right way, or how can I format my data the right way so that when I output it to XML, it doesn't blow up. How do I output it so that I don't get that double root issue I'm sure you're all familiar with? And the answer to that question, I realized much later, is that you have to understand that there's more to DataWeave than just the script. It's not like a traditional programming language, because there's a little bit more going on. It has this reader and it has this writer, and those are really doing the job, the heavy lifting of taking these MIME types, parsing them into DataWeave's data structures, which are just data types, and then doing the same thing the other way. So for example, let's say we have an XML payload. In the data in section, that payload is just XML. It's a raw stream of bytes. The MIME type tells us that we can expect XML, but for all intents and purposes, we don't really know what it is. So the reader gets injected with that data, and it's told that it's application XML. And the reader goes throughout all that data, it parses it into DataWeave's own data structures, it makes objects, arrays, attributes, namespaces, all of those things all of those core data types that we're familiar with in DataWeave. And at that point, the script that you wrote as a developer is now able to work on that data. And when it's done, it passes those data types to the writer, and it does the opposite job that the reader did. It goes ahead, let's say it's outputting application JSON. It changes all of these, it'll chop off any attributes you might have. Any namespaces will be removed from the output. All of your arrays remain arrays, objects in JSON, so on and so forth. So the real magic behind what DataWeave is doing is not really the code that you write. It's instead that they manage to make serializing and deserializing these data implementation details of the language. So the key point here is that DataWeave creates this uniform API that is used to manipulate all MIME types. And it does that by using a reader and a writer to translate back and forth between MIME types, which exist outside of a DataWeave script, and data types, which exist within a DataWeave script. And this is all done as an implementation detail of the language. And what I mean by that is there's very little manual work that you need to do. So for example, like when you're using the functions map, filter, and reduce, all of those functions loop over data, but you don't have to manually tell it how to loop over the data, it just does it. So the same kind of flavor here, you don't have to tell DataWeave exactly how to parse your JSON, but you might give it a few hints. Or CSV, for example, you might give it a few hints and say, hey, what we're expecting doesn't have a header, so parse it as such. And if you're writing JSON, you might say, hey, I don't want any nulls to make it into my output. You can do that as well. You don't have to do it explicitly because DataWeave does a lot of that heavy lifting for you. So our first trivia question. According to this talk, and that's in italics for an important reason. According to this talk, what are some of the primary benefits of DataWeave? A, remove the need to manually deserialize data by making it an implementation detail of the language. B, bring functional programming to the Mule runtime. C, provide a consistent API for transforming many different data formats. D, which is A and C, and E, which is A, B, and C. This is like everyone's least favorite chemistry question. If you think it's multiple choice, and there's only going to be 4, but there's 5. And 2 of them are the same answers. So Brian, Aaron, I don't know how you want to do this from this point forward, or if you need
just let us know what the correct answer is, and we'll look at and see who has the first correct answer.
All right, looks like everyone's.
Most everybody has already answered.
Answering. Paul Downing said, what is happening? That'd be F. F, what is happening? So the correct answer is D, A and C. Now, E is also correct if I didn't put that part in italics in the beginning, according to this talk. I'm not talking about functional programming in this talk, so maybe a trick question if I wasn't so specific and deliberate about it. But E is true in the sense that DataWeave bringing functional programming to the Mule runtime is a pretty powerful aspect of the language as well. It definitely allows us to do, it definitely fits in really well to the data transformation niche. So that can be correct as well, but the correct answer is D, A and C. Remove the need to manually deserialize data by making it an implementation detail, and it provides a consistent API for transforming many data types. I say API there. I think it's important to talk about really quick what an API is. In the Mule world, we mostly think of APIs as HTTP APIs. So we make these HTTP calls, gets, posts, puts, and we either send data to a server or we get data back from a server. But APIs are just an application programming interface. So a function, for example, is an API, and a programming language is an API. It's an API for getting the computer to do what you want. And a function is an API for executing certain functionality. So in the context of this talk, it's good to keep in mind that when I talk about API, I'm not really talking about API in the sense that MuleSoft generally talks about it through HTTP. I'm usually either talking about the way you're interfacing with functions or the way you're interfacing with the language itself. All right, let's keep going. Any questions so far? Okay. If you have any, feel free to drop them.
Yeah, none so far, Josh.
Okay, so the important types that we're going to be covering, important MIME types that we're going to be covering in this presentation are application DW. And if you haven't heard of that one, don't worry, I'm going to go over it. And the three that you probably have already heard of, which is application JSON, application CSV, and application XML. So there's important data types as well. Those are array, object, string, number, and Boolean. I'll be concentrating on those for the most part. So some quick notes about application DataWeave, or application DW. This is like DataWeave's MIME supertype. And what I mean by supertype is that in order for DataWeave to be able to represent all the different possibilities that these data formats can take. And what I mean by that is like a lot of them have this concept of key value pairs, for example. So JSON has their JSON objects, which have keys and values. CSVs have the concept of key value pairs as well. If you look at how headers are associated to each value in a particular row, that's like a key value pair. And then XML has this concept as well through tags. Now, DataWeave has to support every possibility that all of these particular formats might have, even if they don't apply to other ones. So for example, JSON and CSV have no notion of attributes or namespaces, but DataWeave still has to support them because XML does. And what we're going to see throughout this talk is that DataWeave has to kind of bend over backwards in a lot of ways to support XML. I worked with the DataWeave team briefly, and like it's kind of like an internal joke that XML is like the redheaded stepchild of MIME types when you're when it comes to dealing with them. So the application DW MIME type, like I said, it supports all of the features that all of the MIME types it's going to use represent. There can't be any data loss. But if you look at the input, or if you look at the script here at the bottom, and you look at the output on the right, they're nearly identical. What you'll notice is that the output only contains data. So if you look on the left-hand pane on line 2, we have that output application DW. That's more like metadata, and it's really just a declaration there to inform the writer of how the output should look. So that doesn't really make it into the output. Things like variables, things like functions, in most cases, if you're declaring functions in the header, those are not going to make it to the output. An exception to that is if you have a function as a value. So for example, I could have that person key point to a lambda if I wanted to, and that would be valid. The output would be a little strange, but it's perfectly valid. So the reason I bring this up is because this application DW MIME type is fantastic for debugging. There are times when, let's say you're working with XML and you get that can't output multiple roots error. A really great next step to figure out what might be going wrong is to output application DW instead of outputting application XML. That's going to give you a really clear view of how DataWeave is sending your data to the writer before the writer parses it. And if you see that indeed you have this object at the root that has 2 keys, you're going to realize, oh, that's why I'm getting that error. I need to find a way to work around that. Once you get to the point where your application DW output only has 1 key instead of 2, then you can try outputting it as XML again. And in all likelihood, that double root error is probably going to be fixed. Any questions about application DW? We'll dip into this a little bit later with an example. Yeah, that's a good question. So if application DW supports all MIME types, can't we just always use application DW instead of application JSON or application XML? I would say while you're working within your Mule application, that's acceptable. But chances are when you get to the point where you're sending data over the wire or reading data from somebody else, they're not going to be sending application DW because they don't know what it is. That's a good question, though. So you can use it internally. I find that the large majority of clients that I've worked with, they're either using application JSON or application Java to do their like intermediate types. So a little bit more about application DW. It's kind of good to think. I've called it a canonical model before, and then somebody called me out on LinkedIn, and I kind of thought more about it and realized he was right. Canonical model is not the way to put it, but it is kind of a super type, like I was saying earlier, and it's really used as like the glue that holds together the DataWeave script to the reader and the writer. Because when the reader takes in something that's XML, what it's really doing is just parsing it into application DW and sending it to the DataWeave script. So when you're working with the data in the DataWeave script, it's not XML anymore. So if you've ever worked with code or written code that refers to variables as, like person JSON or person XML or data XML or something like that, it's really not an accurate representation of the data that you're dealing with. Remember, the XML, if we go back here real quick, the XML exists outside of the DataWeave script. It's a MIME type. But when we're working with DataWeave, we're working with data types. So if you're naming functions and variables by the MIME type that they represent, it's a bit misleading. One, it causes a problem because it's not as flexible. What if you're dealing with CSVs in the future? What if you're dealing with JSON? And two, it just kind of ignores the fact that you're not dealing with those MIME types within DataWeave. You're just dealing with application DW itself. All right. So now for the kind of the meat of this talk. What are the rules for how DataWeave translates to and from each MIME type? This is the kind of hard lesson that I had to learn over the course of a few years. This is something that isn't really explicitly in the documentation. It's kind of left up to the implementer to learn on their own. So my hope is that by showing this to you all and putting it here explicitly, that's really going to help accelerate your understanding of the language and increase how fast you're able to write good programs with it. So here we're looking at JSON, and we're going to look at this exact same table format for the next 3 slides. So let me explain it real quick. On the left-hand side, on the left and right-hand side, we have our MIME types and the different kind of attributes that those MIME types have. So for example, with JSON, we have objects, arrays, strings, numbers, etc. With CSVs, we have fields, rows, headers, those kinds of things. And in the middle, we have how DataWeave represents those particular attributes of a MIME type using its own data structures. So really, this is a translation table between certain MIME types, DataWeave, and those MIME types as well as output. So for example, if we're reading a JSON object, this gets converted into a DataWeave object. JSON is a great place to start because it's very, very simple. Objects translate to objects, arrays translate to arrays, strings to strings, numbers to numbers, and booleans to booleans. But don't forget that there's this other stuff that DataWeave supports, like dates and date times, attributes, and namespaces. Now, dates and dates times, and other temporal types like local date time, local time, etc., those all get translated into strings before they're sent out as JSON. But things like attributes and namespaces, they don't have any kind of representation in JSON. So the only way that you can, I don't think there's any way that you can see namespaces in the output of JSON, but the only way you can see attributes is by using particular writer properties. So now that we've talked about how JSON is like really very similar to DataWeave in its shapes and data structures, let's look at one that's not so similar. We'll check out CSV. So CSV is like a very basic format. I'm sure most of you are familiar with it, but it's just basically a two-dimensional document. You have rows, you have columns. Each one of these rows is a record, and there's fields in each record, and each one of these fields responds to either a column or a header. Column if the CSV doesn't have a header, but if it does, then it's just a header. So when DataWeave reads in a CSV document, it automatically converts it into an array of objects. And this array of objects has no nesting. The only nesting that's there is between the array and all of the objects contained in it. And that's important. We'll kind of go over that in a little bit later. And if you have an array of objects and you have the output as application CSV, it's going to write it as a CSV document without a problem. So the concept of a row in a CSV translates to objects in DataWeave. And again, these objects have no nesting because a row is just this single row of fields. It's just like a one-dimensional thing. Or is it two? I guess it's two. But because of that, once you start nesting objects, you get into like 3 dimensions and 4 dimensions and things like that. CSV has no way to support those things, and neither do any other flat file formats for the most part. So if you have an object with no nesting, as long as it's within an array, you can write this out as a row in a CSV. The header fields wind up getting translated into object keys, and if you don't have a header on your CSV, they still wind up getting translated into object keys, but they just wind up being they kind of wind up being indexes. So you'll have an object where the key is 0 and the value is the field at column 0, and you'll have the key 1 and the value at column 1, etc. Row fields, they just get translated into object values, and they're always a string. Since really between JSON, CSV, and XML, JSON is the only one that really explicitly supports any kind of type information. So, in JSON, we clearly have strings, numbers, and booleans. But in CSV, it's just a field. There's no real concept of string, numbers, and booleans. They're just fields. So row fields are always just translated into strings. If you want to deal with them as numbers, you're going to have to cast them as numbers and deal with them accordingly. Any kind of number that you have in your DataWeave output, if it gets written to CSV, gets coerced to a string, and then it winds up being a row field. This is also true for booleans and temporal types, date, time, local date, etc. CSV doesn't really have any kind of concept of attributes and namespaces. So if you do have those, and I don't think there's any writer properties that allow you to write those as output to CSV either. So really when you're dealing with CSV in terms of writing it with DataWeave, you're not going to use attributes and namespaces at all. Now, objects with nesting and arrays with nesting are both going to throw an error. So if you have any kind of objects that have other data nested within them, whether it be another object or an array, anywhere, and when you're trying to output CSV, you're going to get an error. And that's because, like I was saying earlier, DataWeave can't translate between this multi-dimensional data structure that you've created, this heavily nested data structure that you've created, and this strict two-dimensional output mime type that it needs to write to. So that's why you're going to get an error there. Now, if you take an array and you use some nesting, that can be okay if it's arrays, like here at the top, if it's an array nested with a bunch of objects, just an array contained with a bunch of objects that don't have any further nesting, that's fine. But if you have an array of arrays, that used to be okay in DataWeave 1.0, but in DataWeave 2.0, that is no longer okay. Okay, before I move on, I'm going to look at these questions real quick.
I think there's two. I can't tell, like from Debbie, mime type is which output data format. I'm not sure if that's a question. And then it looks like BenCat has a question. Can we ignore this problem error while getting metadata?
I ignore it all the time. So yeah, I think you can. There are, I don't know if it was that error, but BenCat, sometimes when you get that error in other like other errors that you wind up seeing like all the time in DataWeave, or not even DataWeave, just Mule as a whole, it's because the Mule runtime is trying to resolve all of these different things at design time, and it can't do it. So for example, a common issue I see is like developers will set things like their Mule environment for their properties and their security properties encryption key as VM arguments, but they won't specify them as global properties in a global file and just ignore them later. And what that does is it causes the Mule runtime to start looking for mule.env and what's the other one, like secure properties encryption value. It can't find them, and it winds up just having error propagating the metadata. Now I don't have the link off the top of my head. There's a really good video on how to get around this. If you message me on LinkedIn, I'll see if I can find it for you and I'll send it your way. But I can't remember off the top of my head what the exact details of it were. But to answer your question directly, I ignore that error all the time. No problems.
Josh,
Okay.
your content is always impressive, and I'm curious if you can give us just a little bit of background. I mean, it sounds like you've had peeks under the covers here, and it almost seems like, you know, unless you've tested each one of these, you know, without a peek behind the covers and then hours and hours and hours behind the screen, you may not know all of this. Can you give us just a little bit of background of, you know, maybe that peek behind the covers if you have had it and now you've acquired all this knowledge?
Honestly, it's just been like years of experience getting it wrong for so long, and just being frustrated with like, why can't I like explain why this isn't working to other people? Why can't I explain to myself why this stuff isn't working? And the more I worked with DataWeave, the more I kind of had the suspicion that there was something else at play that I was just missing out on. And when I talked with the men and women that were developing the DataWeave language, they kept mentioning this reader and writer. So I was like, so what's that? And you know, they told me it's basically what DataWeave is using to translate between these data formats and its internal, and DataWeave's internal data structures. And so it's what takes these, it's what takes a CSV row and turns it into an object. It's what takes a CSV document and turns it into an array of objects. So once I kind of pieced that together with their help, and I realized that there was something in between the data that's coming in and the script and the data that's going out, and it's doing a lot of work for you, that kind of helped shed a lot of light upon the questions and struggles that I had been going through trying to understand what was going on there.
That's great background. And you're helping others not go through those years of trial and error, which it sounds like
Right.
Mostly for you. But yeah, so you also worked with the MuleSoft team just a little bit, it sounds like, along the way too.
Yeah.
Okay.
Because what was happening for me is like kind of what I was alluding to, in the future, in the beginning of the presentation, where I was saying that when I was learning DataWeave initially, I had to learn two big things at once. I had to learn functional programming, and I had to learn this. And I didn't really ever learn this until like 3 to 4 years in. Admittedly, a lot of what I was doing was, you know, when I would get an error, like the output of the XML has a double root or something like that, or can't write CSV because of whatever reason. It was a lot of just trial and error. I didn't have like a concrete mental picture in my head of what the reader and the writer were doing. And it turns out that that's just a really important understanding to have. So it's really the purpose of this talk, is to develop that understanding. And really the kind of like shortest way I know to describe it without going through like tedious examples, which I do in my book, is using tables like these.
Josh, there's one more question. Is it good to use wait function while dropping messages through VM queues?
I think it's almost never good to use wait. but I'm not really sure about the context. So the best I can say is maybe. Without further information about the context, why you're doing it, it might be appropriate in some situations and it might be inappropriate in others, but I can tell you that I've never used it myself, and I've used VM queues quite a bit. If you're waiting for like something, if you're using wait to wait for something else to complete before you drop a message on the queue, that's a bad idea. Don't do that. If you're using it for some other reason, it might be okay. I can't think of a good reason to use it. All right, so now we get to the real nitty-gritty of XML. So as you can see, this I kind of alluded to this earlier, that XML is really like the problem child when it comes to DataWeave and the MIME types. And we're going to get into all of that. XML is the one format that when I say I like struggled for like a year or two trying to get this stuff, it was with XML. JSON's easy, right? You look at JSON and you look at application DataWeave, and it's really hard to spot a difference. It uses curly braces for objects, it uses square brackets for arrays. The strings look the same. They're nearly identical. So we all love working with JSON. It's fantastic to work with JSON when we're doing DataWeave. And CSV is okay. You just need to keep in mind some of the limitations there of it being a two-dimensional data structure. But when you get into XML, things start to get a little ugly. So let's dig into it. I will do a few examples in the DataWeave program, DataWeave playground for this, just to kind of illustrate some of these points, because they're a little hard to talk about, but they're a lot easier to show. So I'm going to show them to you. I'll probably show them to you once or twice. And please use that opportunity to ask any questions if anything's confusing there. So when we're reading XML, and you have an XML document, this just gets translated to an object with one key that's at the root. So all of your XML documents, when you translate them to DataWeave, and then you output them as application DataWeave, for example, they're always going to be an object that has one key at the root. Let me show you this real quick. So let's say I take this XML here, and I call this root data. I thought it'd finish it for me. All right. So if I do this, let me see if I can zoom in on this. I'm sure this is unfortunately small. Okay, yeah, great. Okay. So if I take that payload, and again, this is a great debugging trick. I'll put it as application DW. So look here, this is an object, right, in DataWeave, and it just has this single key at the root. It has another object nested underneath it, and this is really where that first object that's nested underneath it, that's where all the good data is going to be in terms of the valuable data. The root's just kind of like your container, and then you have your data all underneath that. So that's what I mean by DataWeave is always going to transform, when it's reading an XML, it's always going to transform it into an object with a single key at the root. I don't want to have to keep going back and forth. Well, we'll just keep going. All right, so XML elements, these just get translated into objects. That's fairly straightforward. XML tags wind up being object keys, and XML tag content, which is like any data that's in between the two tags, these all wind up getting translated into strings. So it's just like CSV in the sense that there's no type data. Remember, JSON is the only MIME type that really has any kind of type data associated with it in terms of scalar values like strings and numbers and booleans. So since XML doesn't have any of that kind of information, I think maybe if you use a schema, it might, but because of that, everything gets translated into strings. So if you want to work with XML values as numbers, make sure you cast them to numbers. repeating XML elements, this gets translated to an object with repeating keys. I'm going to give an example of this one as well. I'm trying to think of a cleaner way to do this. I think I got something. Okay. Great. Okay, so objects with repeating keys when we're reading them in. So let's say we have multiple data entries. This is perfectly valid XML, right? So when we output this as application DataWeave, we have these duplicate keys here. Now this is, I'm used to this at this point, but the first time I saw it, I was shocked. Because I was like, what, duplicate keys on an object? That's impossible. Like, because I've been working with hash maps in Java and dictionaries in Python for who knows how long. Not that long. But in DataWeave, it's perfectly acceptable to have these duplicate keys. And what's curious is that even if you output this as application JSON, you still have those duplicate keys. Now, maybe this should have been a quiz question, but I'll just do the question and the answer right away. The question would be, is it legal, according to the RFC for JSON, that the JSON spec, is it legal to have duplicate keys in an object? And the answer is yes and no. It doesn't say. It doesn't say if it's okay. It doesn't say if it's not okay. So what you'll find is, like, when you're using some of these JSON parsers out in the wild for Java, some of them support duplicate keys, other ones do not. DataWeave has to support duplicate keys because it's the only way that it can represent these XML formats with its own internal data structures. So it takes the lenient approach when it comes to JSON and duplicate keys, and it supports them because it has to for XML.
Josh, I would think it's probably fair to say that you don't want duplicate keys in JSON, though, because as you're going to parse duplicate keys in JSON, do you get your data tag that says hello or goodbye? And furthermore, I guess the second part of the question is, I've always wanted DataWeave to produce an array when that happens. I would love for DataWeave to produce, a data array with multiple elements in it. Can you speak as to maybe why they don't do that?
Not really. I'm not 100% sure. The first part, the part that I can't answer, yeah, you really shouldn't be outputting JSON with duplicate keys. And the reason is because the only thing that can accurately parse those and deal with them is MuleSoft running DataWeave. If you try to do it with Java, you're going to run into problems. If you try to do it outside of MuleSoft, you don't know what kind of parsers and serializers that they're using. So you really got to err on the side of caution. Just because DataWeave allows you to output duplicate keys as application JSON doesn't mean that you should. So definitely wouldn't recommend doing it. I think there's a writer property that would allow you to tell it, hey, if you have duplicate keys in JSON, I just want you to treat them as an array. So does that answer your question, Aaron, about because there are writer properties that you can use to get around it, so you don't have to do that transformation manually. But as far as reading them in, I'm not so sure.
That'd be awesome. Maybe I'll follow up with you after this. If you can provide an option to the writer to produce an array, that'd be awesome. I actually reverted something recently to a Node.js script that used XML to JS.
Okay.
And XML to JS gives you that option to produce an array essentially when I needed an array.
Yeah. I'm almost 100% positive that there is one. So we have time. So let me check this out real quick.
Yeah, I can follow up on that with you.
Yeah. Yep, here we go. Let me bring this over here. So your array properties for JSON, you have duplicate key as array. It's by default it's set to false, so that's why we get these duplicate keys. But if we do, is it duplicate key or duplicate keys? Key. We get this instead.
Ah, very cool. And Ben called that out in the chat too. Kudos to Ben also.
Oh, thanks.
Very cool. Nice job.
Oh, there we go. I should. All right, I'm listening to Ben from now on.
This is something I've always wondered. So very enlightening. Thank you.
Yeah, there might be one for reading XML, but I don't think so. The nice thing is that with map object now in DataWeave 2.0, we get access to the index of these keys as well. So there is some distinction between, you know, a piece of data. There is some distinction. You can make a distinction between this, which is the data key, and this one, and that's just their position within the object itself. So that's probably useful information to know. Okay, so we dealt with repeating XML elements. XML attributes just map directly to DataWeave attributes. There's nothing really crazy there. XML namespaces also map to DataWeave namespaces, also nothing surprising. And CData maps to CData. So let's talk about writing XML, which is usually the problem. Because it's real easy to read it in. You know, somebody gives us a valid XML document and it just gets transformed into DataWeave data types with you know no requirements from us. But when we have to write out XML, we have to be cognizant of the fact that we can't just send it any data. For example, if I'm writing out some XML here, and I just give it an array. Like this is perfectly valid JSON, right? But like what is an array of numbers in XML? A lot of times it's just good to ask yourself those questions. If you're writing some code for DataWeave and you're about to output to some data format, a good question to be asking yourself is how would DataWeave even represent this, or how would this mime type even represent this particular piece of data? And if you think about how XML works with just a bunch of tags and values, namespaces and attributes, you should come to the conclusion that there's really no array in XML at all, right? Like they do repeated objects or objects with repeated keys, or elements with repeated keys, depending on how you think about it. But there's no concept of an array. Okay. So as long as you have an object at the root with just one key, you're going to be good to go. This double root issue that I was talking to you all about earlier, and I've alluded to like 24 times, is this. So this one's fine. But if I have another one here, root 2, I get this error, just trying to output second root 2 while writing XML. So if ever you see that error, this is your problem. If you output this as application DataWeave, great debugging tool, again, you'll see you have an object with 2 roots. DataWeave doesn't know how to turn that into an XML, and neither will any parser that I know of in the ecosystem. So any of your objects get translated into XML elements. Object keys, same thing, XML tag. Strings, as long as they're within an object, it's like an object value, for example, they get translated into, depending on where they sit, if they're an object value or an attribute value, they're either going to be XML tag content or an attribute value, respectively. And so for an object with repeating keys, we get this repeating XML element. So I wanted to demo something with this real quick, because this is really kind of like the trick is, yeah, you're going to have to deal with arrays when you're working with DataWeave. You might have to deal with arrays in the same code that is outputting to XML. You might need to output an array. So we saw earlier that DataWeave deals with this in a kind of interesting way, right? So we do this. We change this to XML here so we can see what the output is going to be. And it gives us this element with this repeating tag, right? Now, the interesting thing is, and this is where I'm kind of going to slow down a little bit. Let me explain what I'm going to do. In order to see what's going on, because clearly there's an array here. We know XML doesn't really support arrays. So there's some kind of intermediate transformation that's going on before this data ultimately gets output. So what's a good way to figure out what's really going on there? What I like to do is I'll take this, what I'm going to do is I'm going to take this output, I'm going to copy it, I'm going to paste it as the input, I'm going to pass through the payload without touching it at all, with this being the payload, of course, and then I'm going to output it as application DataWeave. And what that's going to show us is like what kind of intermediate step is DataWeave taking in order to get this output as XML. So I'll copy this real quick, put this over here as the payload. I'm just going to comment this out because I'm going to use it a little bit later. I'm just going to pass the payload right through. We should see the same XML. Great, expected. But what if we do DataWeave? And we get this double root thing, an object with duplicate keys. So what DataWeave is doing is it's taking this array and it's coercing it into an object with duplicate keys before it translates it into an object with duplicate keys before it even starts writing out XML. So this is kind of like this intermediary representation that happens before it hits the writer, or maybe it happens within the writer. I'm not sure of those details, but it happens before the translation actually takes place. And so you might ask, like, hey, Josh, what are the rules behind that particular intermediate transformation? And what it does is whatever key is pointing to the array, whatever key is pointing to the array, which in this case is data, is the key that's going to be associated with every single value in the array. It's going to coerce the whole thing to an object, and it's going to associate the key with every single value. So data hello, data hi, and data hey, and that's what we see here. This is really important. This is something, this in the XML duplicate root problem are issues that gave me a really hard time for a while. Does anybody have any questions about this particular functionality of the writer before I move forward?
Hey, Josh, there's two questions in between my chat with one people was having a recording problem. One of them was, is there a way, I'm not sure if you see from Bencat, is there a way to skip main object if we have object of object and he has his, looks like his DataWeave in there? Or for null fields other than if condition. He looks like he clarified it. Oh. Right at the bottom there.
Is there a way to skip the main object if we have an object of object?
And then he has a clarification. Looks like down at the bottom of the chat.
I'm honestly still not really clear on what the question is.
Okay.
Is there a way to? Yeah, I'm not sure what skipping the main object would be. Yeah, there's skip null on. I think that's, I know they have skip null on for JSON. I'm pretty sure they have it for XML as well. And it's just like, there's multiple, there's more values that it can take on because I think you can skip null attributes as well. So let's see, writer properties, skip null on. You can use elements, attributes, or everywhere. So let me just walk through those real quick. So we'll take this. These are good questions. If you guys have any questions about the writer properties, reader properties as well, I'm definitely happy to go over those. So let's see, skip null on, and then we could do, was an attribute a good value? Skip null on attributes with an S, all right. Our is it skip on null? I always, oh, right. I get the two backwards a lot. Okay, so in this particular one, a good example would be if we had some attributes attached to this data entry. So let's just say ID is equal to 1. So we see, again, remember, the key gets applied to every one of these things. So technically, within DataWeave, attributes are part of the key itself. So those attributes get duplicated as well. Keep that in mind. So let's say we have one of these things set to null. It's gonna be null. We'll set that to null. Oh, it didn't like that. Either way, no, it's fine. It didn't make it to the output, right? If we change this to 1, it'll be there. If we do it null, it won't be there. We can skip things like, I think it's elements as well. Yeah, you can do elements. So if I had, let's say I have another piece of data here, that would be data 2, and that just says goodbye. We have that data 2 there, but if I do null elements, skip on null elements, and I set this to null, we're not going to see data 2 in the output. If you wanted to just skip null on everything, skip on null everywhere, and that kind of cleans things up for you. Or skip null on. See, I say it wrong every time. Very similar thing for JSON, by the way. Just there's obviously no attributes there.
Hey Josh, just a time check. We're at 7:35, so I think you're still doing good, but.
Oh no, we're doing great. This
okay.
is we're getting ready to wrap.
Perfect.
Up. Okay. So the rest of it we can kind of breeze through. Namespaces in DataWeave get translated into XML namespaces for XML output. C data to C data. Again, no type information in XML. So temporal types like date and datetime just basically get cast into XML tag content, which you could think of as a string, but it's really not. Same with number and Boolean. So if you have an array without any nested arrays, this is kind of what we just went over as well. DataWeave is going to try to translate this into an object with repeated keys if it's possible, and then it's going to wind up being a repeated XML element. Now, if you have an array nested with an array, DataWeave just says, I'm not touching it, and it's going to throw an error. Because there's really no way to represent it. If you look at, if you really think about how DataWeave was able to do this, deal with this particular array, I'm going to clean this up a little bit so it's easier to see. Deal with this particular array by associating this key with every one of these values and creating an object. If you have a nested array, like what key is it going to associate with everything? Is it going to flatten the array? There's a lot of options for what it can do. And so it's really on the developer to kind of massage that data a little bit more into the correct format so that it can be correctly represented by application XML. All right, so the key point here is that DataWeave programmers really have to have a deep understanding, or just MuleSoft developers in general. They really have to have a deep understanding of how DataWeave translates in between mime types and data types. A lot of times, when I talk with developers, they kind of ignore the aspect of the reader and the writer until they, come across something where they get stuck. I would say it's definitely better to be proactive and review these translation tables, make sure you understand them, make sure you can test these things within the DataWeave playground yourself. Make sure you know how to use application DW, whether it's to represent data within your application itself, but not leave your application, or if it's just as a really useful debugging tool. Again, if you're ever curious about how DataWeave is representing this data before it gets into the output, a really great way is to use application DW as your output data type, and put a debugger or a logger and just log the payload afterwards. It's super helpful. I think we're coming up on our last trivia question. This one shouldn't be too hard. Which of these MIME types has no direct mapping to DataWeave's array type? I'll Some of y'all weren't paying attention. All right. So the answer is C. Let's review it real quick since quite a few people got it wrong. Application JSON has a very clear translation from JSON arrays to DataWeave arrays. And that should be fairly obvious just by the name. Application CSV, this one's a little bit trickier because, you know, when you look at a CSV, there's no real concept of arrays there. But DataWeave does manage to use the array data type as like it's kind of like the holder for all of the data. Because when you look at a CSV, it's sequential data, right? You have 1 row, 2 row, 3 row, 4 row, etc. And the array is the same way. You have an index at 0, 1, 2, 3, 4, and 5, etc. So that's how it translates in between the two. They're the same thing conceptually. Application XML is the correct answer. DataWeave itself even has to kind of like translate arrays into objects before it writes out to XML. And I think I got one more trivia question here. Yep. Is it true or false? It kind of got easier as we went on. You know, we went from 5 multiple choices to 3 to, oh, you guys are already answering. Okay, here we go, speeding up. When outputting the application CSV, DataWeave can automatically coerce nested data into flat data and write it as a row. Is that true or false? All right, we're going to find out. I don't know either. Okay, so let's say let's do something that's going to work. Name, we'll honor Aaron here. And we'll honor the whole big Compass crew. We'll do Aaron. Now there's like 3 ways to spell Stefan. Okay, Stefan. You can't forget about them. So this one works out all right. But the question was if we have these kind of nested arrays. So let's like add another value. We'll add hobbies to just one of these, and we'll make this will be an array net. And there you go. There's the answer. So it's false. DataWeave cannot coerce an array, a nested array, in its own data types into. It can coerce them into something that would work for application CSV. Okay, that's the last trivia. Any questions?
I think that's it. Have a great night. And thanks again for everybody joining. We had good attendance tonight. I think we peaked at just about 50 people. So, thanks again. And we'll be posting information on the next.